Hello everyone. Today in this video we are going to apply Kirchhoff's rule to solve a problem on network of resistor. So let's quickly see what are the rules. So this is the Kirchhoff's first rule, which says that the sum of current entering a junction is equal to sum of current leaving the junction. And second law says the algebraic sum of EMF across a loop is equal to algebraic sum of product of current and resistance across the loop. So for that we have to use the sign convention. So cell giving current in the direction of loop is positive. So as you can see out here, cell always gives current from positive side. So out here the direction of current is like this, and the loop is also towards the same direction, so this EMF is positive. Now in second diagram you can see the direction of loop is towards the right, but this cell will give the current towards the left, so this I have to consider it to be negative. And sign convention for current is, so the current in the direction of loop is positive, so as you can see out here, so this loop is going towards right and the current is also going towards the right, so this is positive current. And the current towards the direction opposite to the direction of loop is negative. So out here you can see my loop is clockwise and it is going towards my left, but the current is going towards the right, so this current is in the direction opposite of the loop, so this is negative. So we'll be using all this to solve the question. Now we will solve one question on network of resistor using Kirchhoff's rule. So it's not necessary to use both the Kirchhoff's rule in the same question, so it depends on type of question. So in this question we will be using only voltage rule, not the current rule. So out here you have to find the current in each branch, like branches are AB, AC, AD and DB. So I'll redraw the circuit. So this is the circuit and I'm taking the first loop ACBA. So using voltage rule in ACBA. Now as you can see, so this cell is giving the current towards left and my loop is going towards right out here. So this 10 volt is negative, so minus 10. So I don't have any other EMF, so minus 10 is equal to, so now let's see this resistance first. So current I1 is flowing towards the left, but my loop is going towards the right, so out here this current is negative, so it will be minus 1 I1. So out here in this resistance 2 ohm, current I2 plus I3 is coming down, but my loop will go up, so out here the current is negative, so minus 2 I2 plus I3. Now if you come to this resistor, now my loop will go downwards and this current is going upward, so this is also negative, so it will be minus 4 I2. So now I'll simplify this equation and I'll get this as final equation: I1 plus 6 I2 plus 2 I3 is equal to 10, and this is the equation number 1. So as I have 3 variables in the question, so I should have 3 equations. So one equation I've already got. Now I'll take the second loop. Now if you take this loop, now this cell will give the current in the direction towards my left, and this loop is also towards the left. So if you see the upside, so it will go this side, so it is plus 10. And if you come out here, so the current is going downward and loop will also go downward, so it will be positive 4 I1 I2. And if you come this side, so current is flowing downward and our loop is going upward, so it will be negative, so it will be minus 2 I2 plus I3 minus I1. Now if you go this side, upside, so in this resistance 1 ohm, so current is going towards left and this loop will also go towards the left, so it will be positive 1 I1. So if I simplify this equation, so I'll get 7i1 minus 6i2 plus 2i3 is equal to 10. So this is equation number 2. So I need one more equation. So you can either use this loop, so but I'm taking the big loop a d e b a. So this loop I'm using. So it's up to you, whichever loop you like you can take, and whichever direction you want you can take. You can take downward direction also, but I'm taking this as anti-clockwise. So now let's see. So out here I have one EMF, so it is, now this EMF will give the current in upward direction, and my loop is also going upward, so it will be positive 5 is equal to, now out here the current is coming towards the right and my loop will go towards the left, so this current will be negative. So this is 4 minus 4i2. And if you come to this resistance, so current is going downward and this loop will also go downward in this direction, so this will be positive 4i1 minus i2. So now I'll solve this. So simplifying, I'll get this. So this is the third equation, so I'll write all the equation together. So this is the equation. Now I need to solve this equation. So solving is up to you, so whatever method you know you can do it. So for the timing I'll be adding equation 1 and equation 2. As you can see, this is 6 and minus 6 plus 2 minus 2. If you add this, so i2 and i3 will cancel, so you're left with 8i1 is equal to 20. Now i1 is equal to 20 by 8 or 5 by 2. So now I got i1. Now I can use this value of i1 in either of the equation, like, so using i1 is equal to 5 by 2 ampere in equation number 3. So in this equation I don't have i3, so I can solve this. So putting the value of i1, so you will get i2 to be 5 by 8 ampere. So this is i2. Now you got i1, you got i2. Now you can use i1 and i2 in any of the equation. So I'll be using equation 1 or 2. So let's see. So this is i1, i2, and we're using i1 and i2 in equation number 1. So after putting the values, I'll get i3 to be, so 15 by 8 ampere. So this is all the current i1, i2 and i3. So the problem is I have to find the current through each arm. So that means current in arm AB will be i2. So that i2 I already know, it's 5 by 8 ampere. So now current in BE, so BE is i3, so you can directly put the value. And current in AD, so AD is i1 minus i2, you put the value, you'll get the current. And I DC, between D and C, this is i2 plus i3 minus i1, so putting the values, so I'll get the value to be 0, so no current will flow through this loop. So again last BC, so in BC it's i2 plus i3, so putting the values, so it is 20 by 8 ampere. So this is how we use Kirchhoff's rule to solve the network problem. And now you can try same question with taking the loop in different direction. So all the loops are in upward direction, so instead of taking the big loop I have taken this small loop. So try this question and see whether the answer will come same or not. So answer should come same.